Good morning, ladies and gentlemen, and welcome to day 2 of the 4th SBI Banking and Economics Conclave 2017. Over the last 3 years, this gathering of the top minds has become the benchmark for thought-provoking and innovative dialogue. And last evening, we had the privilege of hearing some very interesting ideas from the men and women at the forefront of India's aspirational march. In fact, it was this aspiration which found resonance in FM Jaitley's address as well, when he said that the governments of the future need to actually continue along this path of reforms, adding that India has the capacity to sustain this growth for the next decade or so. At the same time, he also promised a lot more spending for healthcare, for education, with an emphasis on rural infra. In his keynote address, Professor Paul Krugman said that the Indian economy actually has the potential to grow at 8–9% easily. And there were also 2 very interesting discussions and very interactive ones that we had with Maharashtra Chief Minister Devendra Fadnavis and Commerce Minister Nirmala Sitharaman. But the underlying message from all our speakers was unanimous. India is on the fast track. A lot has been done, but a lot more still needs to be done. So today promises to be equally packed with power ideas and tools for change. So before we begin, may I request all our audience members who are active on social media to please use our hashtag SBI Conclave. In fact, it's interesting because yesterday, despite a lot of the global events and hashtags like PM in Israel, there's China, our hashtag was trending as well. So you can imagine the traction that the conclave has received on day 1. So please do continue using this hashtag. So to begin today's proceedings, may I first invite Ms. Arundhati Bhattacharya, Chairman, State Bank of India, for a welcome address.
Good morning. I extend a very warm welcome to all our distinguished invitees, ladies and gentlemen, on the second day of the 4th SBI Banking and Economics Conclave 2017. The SBI Banking and Economics Conclave is the flagship annual event of State Bank of India, a one of its kind in the industry. Spread over 2 days, the event provides a platform for brainstorming of contemporary economic problems facing the country. Yesterday, the conclave hosted Dr. Paul Krugman, whose keynote address touched upon the fact that the era of hyperglobalization is plateauing, and therefore the window for India to become a developed nation is narrowing. The Honorable Finance Minister shared his inaugural address with us. This was followed by 2 sessions of one-on-one conversation with the Honorable Chief Minister of the State of Maharashtra and the Minister of State for Commerce and Industry. Today, we are to begin the second leg of the conclave with 1 keynote speaker, a tete-a-tete with the Finance Minister of Uttar Pradesh, and 4 panel discussions. Let me now set the tone of today's proceedings with an anecdote. In 1988, economists Gerald Faulhaber and William Baumol, in their study, Economists as Innovators, Practical Products of Theoretical Research, asked a simple question: how much have economists contributed to the flow of innovation used in business and government? To this end, Faulhaber and Baumol selected the noteworthy innovations, 9 noteworthy innovations, and studied their history from origin and adoption and diffusion, treating these innovations produced by economics like any other scientific or technological innovation. What they found was an eye-opener. While economics did play a part in the conception of innovation, it was less important than they had anticipated. Economics seldom acts alone as a driver of innovation. This conclusion, often known as the Faulhaber-Baumol's quandary, establishes that economics in its most theoretical form plays a secondary or even tertiary role in innovation. The first session this morning, the keynote address by Sri A.S. Kiran Kumar, Chairman ISRO, who I shall introduce in a minute, will remedy this. It will remedy this quandary and try to bridge the gap between economic discourses as we normally see and talk about and the deeper determinants in the scientific economic innovation and progress. The path to New India will be elusive unless it is secured by this bridge between theory and practice. Space technology will play a very important role in the years to come. It touches every aspect of our life without being noticed. This technology finds application in various domains, such as smart cities, urban planning, resource mapping, blue economy, navigation, estimation of local taxes, telemedicine, and even monitoring of industrial activity. Hence, it is essential to secure self-sufficiency in space technology, and ISRO has upheld this mission of bringing space to the service of the common man, to the service of the nation. In the process, it has been one of the largest space agencies in the world. ISRO maintains one of the largest fleet of communication satellites, the INSATs, and remote sensing, IRS satellites, that cater to the ever-growing demand for fast and reliable communication and Earth observation, respectively. ISRO develops and delivers application-specific satellite products and tools to the nation, broadcasts, communications, weather forecasts, disaster management tools, geographic information systems, cartography, navigation, telemedicine, as well as dedicated distance education satellites being some of them. It gives me great pleasure, therefore, to introduce Sri Kiran Kumar, a distinguished scientist and director, Space Application Center, Ahmedabad. He assumed the office of the Secretary, Department of Space, Chairman, Space Commission, and Chairman, Indian Space Research Organization on January 14, 2015. A highly accomplished space scientist and engineer with a distinguished career spanning over 4 decades in ISRO in the satellite payload and applications domains. He has made immense contributions to the designs and development of electro-optical imaging sensors for airborne, low Earth orbit, and geostationary orbit satellites, starting from Bhattacharya TV payload to the Mars orbiter mission payloads. Sri Kiran Kumar was instrumental in evolving the successful strategy for steering the Mars orbiter spacecraft towards the planet Mars, as well as its Mars orbit insertion. He also has made significant contribution for evolving the observation strategy encompassing land, ocean, atmospheric, and planetary studies. Under his leadership, in all likelihood, India will have its own indigenously made GPS, or Indian Regional Navigation Satellite System, the IRNSS, with an operational name of Navik by next year. IRNSS system is expected to provide a position accuracy of 5 meters in the primary service area. It is designed to provide accurate position information service to users in India as well as the region, extending up to 1,500 kilometers from its boundary. Sri Kiran Kumar will speak on these matters, but before I hand it over to him, I must tell you that ISRO is an organization of which we are inordinately proud. We are inordinately proud because in spite of all the roadblocks that have been put on its innovation by various advanced countries, it is where it is today on account of its pursuit of excellence. And that is something that we need to imbibe. That is a lesson that India needs to learn at the earliest. And that is the reason why we look forward to you, sir, to tell us how you have steered this organization that you head towards excellence, towards being one of the organizations from India that is respected and looked upon as cutting edge and worthy of being followed world over. Thank you.
Thank you so much, Ms. Bhattacharya. So like Ms. Bhattacharya said, our keynote speaker this morning has spearheaded India's space prowess. ISRO's Made in India, for India mantra is courtesy the vision of our next speaker. It's my privilege to welcome Mr. Kiran Kumar, Chairman of ISRO. May I please have you on stage, sir? May I also request Mr. Rajnish Kumar, Managing Director, National Banking Group, to please accompany Mr. Kiran Kumar on stage. And Ms. Bhattacharya, may I please request you to present him with the traditional shawl and a green certificate. Now, this is very interesting because about 2 years ago, SBI actually did away with the practice of flower bouquets. Instead, they embarked on a green mission. So what they do is they plant 101 trees, and that certificate is handed over to the guests, which is what you're seeing Ms. Bhattacharya hand over to Mr. Kiran Kumar. So this is not just a token of appreciation, but a commitment, SBI's commitment actually to the environment. Thanks so much. The floor is all yours, Mr. Kumar.
Good morning to all of you. At the outset, let me thank Arundhati Bhattacharya for the excellent introduction that is given, and also giving me an opportunity to be here amongst you and talk to you about ISRO and how ISRO has been conducting itself and trying to achieve the basic objective which was envisioned by Dr. Vikram Sarabhai on making India, bringing India to a level where use of advanced technology for the benefit of the society. Not changing. Okay. Yeah, it's okay. Now, today's topic itself is Pathfinder, and what I'm going to talk about is role of space technology in furthering economic development and impact on common man. It's very clear that in today's world, Internet of Things, big data analytics is going to be a key thing. Cloud computing, robotics, and artificial intelligence. Space technology is an enabler for all of this, including communication network, where by making use of the space as an entity, providing a set of observing systems or communicating systems, enabling this. Probably takes more time. Okay. Now, the technologies and development sectors, if you take, we have been addressing health, education, transportation, and in all of this, again, as I have said, Internet of Things or big data, cloud computing. Then in applications, we are looking at telemedicine, teleeducation, vehicle tracking, disaster, urban maps, climate studies, and also the advantages what we have is reaching to unreachable data collection in real-time tracking and fast output. Then again, if you look at the key components of our systems are Earth observation, satellite communication, disaster management support, and then satellite navigation, climate and environment. These are the areas in which we have been able to provide significant inputs. Starting from scratch, way back in 1963, when we put the first sounding rockets from our country, today we have reached a stage where we have achieved about 154 missions, about 90 satellites and 60 launch vehicles. And out of that, we have the Polar Satellite Launch Vehicle, which has done 39 consecutively successful missions. And we have the GSLV Mark II, where again we have demonstrated that by the 4 consecutively successful indigenous cryo-engine-based missions. And just last month, we had the Mark III, which can put up to 4 tons to geostationary transfer orbit and up to 8 tons for low Earth orbit. And we have also, while we have been building the basic capability, we have not ignored the need for future development, because cost of access to space is an essential thing. And unless you bring down the cost of access to space, doing more work from space becomes difficult. And in this process, we have done last year reusable launch vehicle technology demonstration and also air-breathing propulsion technology, making use of atmospheric oxygen for the engines that are required. While we built our capability of polar satellite launch vehicles, so far, apart from our own satellites, we have also launched 209 satellites for 29 countries. And our Earth observation capability today has almost 18 satellites in orbit capable of giving 3-tier imaging data for our agricultural monitoring, high-resolution imaging. Just in last 1 year, since June of last year, we have put 3 of the very high-resolution satellites capable of providing sub-meter resolution panchromatic and 4-band color imaging capability, which is essential for many of the monitoring and planning activities which we will see later. We have stereo imaging, which generates digital elevation models essential for the planning and realization of various activities with respect to real estate. Ocean color, ocean altimetry, rain above the oceans, sea surface temperature, all of this is done using our Earth observation capability. In terms of communication, again, just in the recent 2 months, we have added 3 communication satellites. With this, we have about 18 satellites in orbit, starting from a very humble beginning of, in 1975, the world's largest socio-technological experiment, which was conducted to demonstrate that space technology can be used to reach out to the entire country in a quick succession. Some of you will remember that way back in 75, we had met a broadcasting service or television service viewable only in 4 metros. Starting from that time, today we have been able to provide broadcasting as well as connectivity for various stock exchange or ATM services. And we are now working on high throughput satellite. One of the first of that we have launched last month, a high throughput satellite which can give multi-beam capability. And later this year, we will have another satellite which will give us more than 90 Gbps capability. So over a period of 4 decades, we have been able to bring in telecommunication, telemedicine, teleeducation, and also for disaster monitoring, the various requirements that are needed. Another important development has been the satellite navigation, where today we have a 7-satellite constellation, which is very different from what others have done. Whether it is US, Russia, or Europe, or China, they all have gone for a global GPS system, but it requires between 28 to 32 satellite constellation. What we have done is, for covering India and surrounding India about 1,500 kilometers, just a 7-satellite constellation operating in a different mode, we have put it in place. And today, there are a number of applications, including for providing fishermen, when he is in the ocean, information about where to go for fishing, as well as on the weather vagaries, he can be advised. And also a number of activities related to railways, roadways, and survey activities are planned in this. Gagan is another system which enables making use of the GPS of US system, providing for both en route planning and landing. This is a service which has been actually certified by Director General of Civil Aviation, and all the aircraft which are going to be registered beyond January of 2019 is required to carry this kind of receiver for application. Apart from these, we also have done work on space science and planetary missions. Chandrayaan-1, you will all be very happy to know that though a large number of missions had gone to moon, even had landed on the surface of the moon, it is Chandrayaan-1 which gets the credit for discovering water and discovering water. The process of water molecule formation on moon is actually credited to Chandrayaan-1. Similarly, Mars orbiter mission, as was pointed out, is an excellent example of showcasing how you can do in a very different way planetary missions at very significantly lower cost, showcasing to the entire country and also to the globe that we can do things in the country in spite of the various limitations that are existing. And today, just on the 19th of November, we completed 1,000 days of operation around Mars, while when we envisioned this mission, the idea was it was going to be a 6-month mission. And another very important satellite is the AstroSat, where the Indian academic institutions, whether it is Tata Institute of Fundamental Research, Indian Institute of Astrophysics, or Inter-University Center for Astronomy and Astrophysics, through them, the payloads were built, and those payloads form a platform. And this platform, again, is acclaimed worldwide because it is one which carries in ultraviolet the highest angular resolution imaging capability. While all this space technology has been brought in, what are we doing with them? Today, for example, using the set of optical and microwave multispectral imaging that is available, that along with the digital elevation model, what we have created using the stereo data and the in-situ sensors and the data collection platform and navigation-enabled positioning and mobile data collection, and using a set of models, these are being put to use for various activities, whether it is socio-economic security, sustainable development, disaster risk reduction, and governance. And we have all these components indigenously built and realized. Okay. Now, what are the kinds of application that we are doing? This is basically on socio-economic security. If you look at agriculture sector and groundwater, energy, health, and infrastructure. On groundwater, over the last 3 decades, we have been able to provide specific information about where to drill the borewell, and more than about 4 lakh borewells drilled in the country using this technology has yielded greater than 90% success rate. And in terms of watershed development, urban master plans, ecosystem management, disaster risk reduction, and governance, decision support, planning, and monitoring, in all these areas, the activity is in progress. And if you look at geospatial data collection platform, we have brought in a platform called Bhuvan, and today Bhuvan hosts, beyond 2016, all the data collected is available on this platform, and it provides a capability for the governments and various departments to monitor and plan the activity. And today, actually, we have got Bhuvan platform for each of the states, and also Bhuvan platform exclusively for railways. And it provides a large number of the spatial content. If you look at between 1 and 2.5 meters, the entire data is covered for the country, and we'll keep updating it every year. And then it provides digital surface model, and then its services it gives is thematic, ocean, disaster, climate, and then it's also open to all web map services, and then it provides linkages to 30 ministries and 29 state portals, and for various support activity. In fact, we also have a feature called School Bhuvan, where school students can actually navigate and do their projects on this platform. And this shows some of the applications. One of the things is ease of doing business. The Ministry of Culture, for example, earlier when you had to do a building, get a clearance for constructing a building in the vicinity of heritage sites, it used to take years. But now, with the help of this geospatial tool, the Ministry of Culture is able to provide clearances for construction within a few weeks, and this has been made online. And similarly, if you look at the micro watershed planning, and also in terms of clearance for building permission, just what I mentioned. This is another very interesting development, and which happened since last August. The Ministry of Rural Development is able to make use of the geospatial tools and the crowdsourcing as well as mobile applications. More than 1.5 crore assets have come into the database, and this is able to provide a very significant information for both monitoring the growth, monitoring the developments, and the assessment of what is needed to be done. And this is since last August. Today, the rate at which the asset map is growing is almost more than 1.5 lakhs per day. And this entire thing is set up in the system. And this is another just an example of how gas pipeline surveillance changes can be detected using a series of images, and then how it helps monitoring, this example showcases. We are also working on providing both the navigation as well as the geospatial information system for supporting the railway activity, whether it is for the unmanned level crossing or for providing accurate information about the railways, various trains and good trains information to the system. Then similarly, if you look at the support for National Mission for Clean Ganga, based on the satellite data, we have a monitoring of the water quality at certain specific location, and also supported by in-situ observation. This will provide a very useful tool for seeing the quality of river at various locations. Apart from this, we are all very clear that we need to make use of non-renewable energy sources have to be reduced, and renewable energy sources we need to use more. And over the decades, whatever data we have collected from our satellites, we are in a position to provide for any given location in India what is the likely availability of solar energy, and similarly simulating the sun illumination for rooftop solar panel installations. And there is also a sort of a tool available on the web for doing this activity. Then in terms of the ocean, wave energy, what is required, and also for providing inputs for various applications, the activities that are done here, including water and wind energy collection information, and providing information about the sea state, both for route planning for the ships and also in terms of high energy from ocean salinity collection, different techniques that are there. All this data is being generated using our space-based inputs. And viewing the ocean from space, thinking blue and developing the nation's economy, again, the smart navigation activities. And see, today one of the things we are providing is not only for our country, but also for the entire globe. Complete ocean wind vector information of the entire globe is provided within few hours of data acquisition, and this goes into the numerical weather models of the globe, and it's an extremely important development. And also wave height is forecast from satellite data in the Indian Ocean. This is again in terms of monitoring how the data is used, geotagging using crowdsourcing techniques, and the states like Andhra Pradesh have actually made use of this technology, and they actually implemented providing the resources required for housing construction based on this approach. And today we are providing it for Pradhan Mantri Awas Yojana, Housing for All, and in this also this 3.6 million homes are geotagged. Another very important development is space-based information system support for decentralized planning, where the ultimate aim is to actually reach out to the village sarpanch and the elected representative of the village, and making them aware of the resources that are available to them and what kind of planning they should do so that the situation for those villages improves. And this is an activity which has been started. Of course, it's still in the making. We need huge support from academic institutions, and we are working with many institutions across the country. And slowly, more and more state governments are also coming across and supporting this program. And the entire asset of database is getting created for the villages, and then subsequently, it will be used for their planning activity. apart from this, both in terms of disaster monitoring and management, forest fire alerts, which goes to the actually forest officers on their mobile, and this is one of the services that is provided using the satellite data, not only our own data, but also data accessible to from other space agencies. So this, using our satellite data, we are also in a position to find out what is the actual burnt area that happens. Meteorological and oceanographic services. Here again, today we have a capability to actually observe India and surrounding India every 15 minutes. And it is this information that helps us ensure that cyclone tracking and cyclone prediction, cyclone landfall prediction can be done at least 4 days in advance to an accuracy of better than 20 kilometers and half an hour in time. In addition to that, a large number of information like cloudburst or heavy rain events, all these are provided. And today, this cyclone warning itself is one of the extremely well-developed technique. And as you are aware, in the last few super cyclone times, we have had probably deaths less than single digit, where it used to be in the range of tens of thousands in the earlier decades. And for monitoring the climate change and understanding its impact and mitigating its impact, no other data better than the space satellite-based data collected over many decades is useful. And whether glaciers are advancing or retreating, such information can be generated using this. While we are doing all this, we are also trying to ensure that we provide opportunity to the Indian academic institutions and researchers to make use of the data, both at Ahmedabad, and just last week we opened as an outreach center in Hyderabad, where entrepreneurs can go to that place. All the data, including high-resolution data, is easily accessible to them, and they also get a computation platform, and they can develop their products, and once they're successful, they can come out and set up their own facility with the necessary regulatory inputs that are needed. But we are providing opportunities for the academic institutions and entrepreneurs to make use of this data and provide various services. So this is one of the system called Research Platform for Academia in Ahmedabad. And disaster management support system. This has been another very effective thing which has been going on for quite some time. We develop not only space-based observation, but we also develop a number of ground-based observation systems to validate and calibrate this and provide information, whether it is on floods or cyclone, drought, landslide. And the National Disaster Management Command Center, there, which is actually operating with a mirror system at Hyderabad. So all these activities are for, in addition to that, we also provide to international initiatives. In the courses of any disaster, we provide the satellite data from our own systems also. For doing all this in the country, we had to build the system from scratch. As you may be aware, that the whole activity started way back in 1963 with the first sounding rockets, which was brought into the country in the form of kits, because Dr. Vikram Sarabhai was able to convince his friends in America, Russia, France, and Germany that in India we have a unique place where magnetic equator is there, and if you do upper atmospheric research in this region, it will be globally beneficial. So with that, we started getting hands-on experience on the sounding rockets. The first sounding rocket went up from our country way back in 1963. And since then, you have seen we have been able to do indigenous development of the entire launch vehicle system. For doing that, more than 300 technologies have been transferred to industry, and many of the advanced material and also the alternate uses of these technology is being done. See, the process of indigenization has been quite tedious, because you can easily imagine that in the area of launch vehicle technology or even in the satellite technology, while we made use of all the opportunities available in the initial stages of Soviets offering us to launch a couple of satellites, and even Ariane providing in the first developmental flight an opportunity to put a satellite, what ISRO has been trying to do all along is make use of the technology that is accessible to us, but build indigenously technology which is not available. And this process of making use of the indigenous capability is again a very tedious process, because we started with about 10 industries way back in 60s. Today, more than 500 industries contribute to our work, and more than 80% of the launch vehicle technology systems are actually built through the industry. We are also in the process of making sure that the industry, a joint venture, is going to build our PSLV, Polar Satellite Launch Vehicle. By 2020, we expect the first launch from such an entity. And we are also trying to see other application activities as well as satellite development being done through the industry. And we are also actually supporting many academic institutions, student satellites development, and we have so far launched about 9 student satellites built by the various institutions in our country. So the process, just to appreciate the kind of resources, many times comparisons are made. See, what India has spent on its space program today, if you add up right from beginning, from the time it started, it is less than, many times less than what America spends in 1 year. So the total amount of money what we have spent so far on the total space program is significantly lower than what America spends in 1 year. So that is the kind of, you can say, resource utilization that has been done. And today, we are in a position to provide the fishermen exact information about where to go for fishing, so that he doesn't have to spend much time searching for it, and he is also assured of a catch. Then, in terms of providing crop assessment, there is a center in Delhi which has been established called Mahalanobis Crop Forecasting Center, which provides that. And today, with the current government realizing the need for using technology in all its activities of both planning as well as monitoring, the usage of space-based information is increasing significantly, and more state governments have also started tying up with us. For example, just the other day, Telangana and Andhra Pradesh, they decided that the entire state's water body, surface water body mapping, along with their in situ information, they are looking at how water and water management can be done effectively. So in the nutshell, what I can tell is that technology is a great boon if we make the best use of it. And the space as a frontier, space technology, which became available in the 50s, we had great visionaries like Dr. Sarabhai, who could think of how this new technology can be brought to the benefit. And over the decades, whether it is education or whether it is communication or meteorology, in all these areas, we have been able to make significant progress and provide to the country the necessary resources and inputs coming from space technology. And today, what we have, not only we have provided to our own countrymen, recently the central government also made a great gesture of providing communication capability to the South Asia countries. So last month, what we launched, GSAT-9, is able to provide a transponder to each of these South Asian countries, and the process of enabling that is just on. The satellite is already in place, and it is performing well. And today, we also have a capability of putting not only our satellites, but also satellites for others, because one of the things we have been doing is, while we build our own capability, we are looking at if we can get some returns on this by using our spare capacity or excess capacity. We have used that, and today, Polar Satellite Launch Vehicle, as you are aware, is sought after by the world, because there is a dearth of launch vehicles providing for small satellite launches. So this also provides a huge opportunity for the Indian industries to capitalize on the capability in the country and then provide exports or provide opportunities for other countries, both in terms of building small satellites and launching them. There is an opportunity. More than that, the huge amount of solutions that are available and the kind of solutions that we have adopted is available for the entrepreneurs to provide it to whether it is neighboring countries or other countries. So the opportunities are many, and we'll be more than happy to support any of the entrepreneurs for doing such activity. And the government, more than anybody else, today is really making use of the space technology capability of India and trying to make sure that it benefits not only we in India, but also people in Southeast Asia. At the end, let me again thank the organizers for giving me an opportunity to just showcase to you some of the activities what we have done. And thank you very much for the patient hearing. If you have any questions, maybe I can answer.
Any questions for Dr.? Yeah, please, mic there.
Sir, this has been a fantastic presentation. And I have two small comments. I'll begin by saying that in the introductory remarks of Madam Bhattacharya, she mentioned innovation and the name of William Baumol. Baumol happened to be one of the greatest economists who just died about 6 weeks back. And he wrote extensively on innovation and the importance of creation. And this is an idea that Baumol was mentioning from a person by the name Joseph Schumpeter, possibly the greatest economist of the 20th century. And for Schumpeter and then following Schumpeter, Baumol, it is creation and the use of knowledge and technology that is supreme for human beings. Now, coming to the second presentation, let me say that I happen to be from the academic world. I'm an economist. I had no notion that ISRO was doing the kind of things that we just saw a brief glimpse of. And I must say that we're extremely proud of the activities of ISRO, particularly because I think they are working in terms of dollar or rupee expenditure way below what the Europeans and the Americans do, which was mentioned by the honorable speaker. So my final comment is the following. You know, being an economist, I have to say the following. Economics is, and this is the economics conclave also, so I have to record the following. Economics is known to be a dismal science, which it is, actually. It is dismal because this is the way economics was understood by Malthus and Ricardo. These were the two great economists who followed Adam Smith. Now, essentially what they were saying is that as human beings progress, their requirements will be very large, and the earth will not be able to provide all those requirements. Malthus said it in a very telling kind of manner about food output and the growth of individuals. Now, my short point is the following. The movement of world history has shown that Malthus did a major presentation. That's why Malthus is still important. But human beings have overstepped and always provided for themselves in a fantastic way thanks to knowledge and technology. And this is precisely what we are seeing. Even though the earth has limited finite capabilities, as long as knowledge and capabilities and technology can be used, we can be up ahead beyond the requirements of human beings. So this is a fantastic takeaway from this presentation, sir. Thank you very much for this. My final real comment would be this. We should not believe that human beings can keep on achieving these things and disregard nature, which has finite capabilities. Human beings are great, but I think we have to accept that nature is perhaps greater, and human beings have to accept that particular thing, but keep on innovating and using technology. So thank you very much.
And thank you for your comments.
Let me just try and keep the question very direct and brief, considering the time.
Yeah, it would be absolutely brief. So when you're taking us to space flight?
At this point of time, I would say our priorities are still not that. Our priorities are how to make the technology and the number of satellites that we need to put for improving our communication as well as Earth observation and navigation requirements. Today, we have about 45 satellites in operation. Probably what we need is roughly 70 to 75 to meet the essential requirements and to ensure that we are able to provide the requisite services for the country. And while the humans in space is probably one of the things that you would be looking for, but at this point of time, it's not a priority activity. And we are actually doing some of the activities towards this capability within the realm of our activities. Like, for example, we had a crew module which was recovered. We are also going to do an experiment on recovering the pad abort test, that is in case of a contingency, how to recover this thing, or how to bring the object from space through the atmosphere. So we are developing these technologies, but finally it is the call that the India and the government has to take when we need to get into this particular activity of humans in space.
Arvind Chari from Quantum Advisors, right at the back. So my question is on Team Indus. By the end of this year in December, you will see them trying their moon mission. I want to know, this wouldn't have been possible without ISRO creating the ecosystem and the experience in Caliber. I want to know your comment as to what you think of such private missions and the success of it, and how has ISRO played its role in spawning the ecosystem?
Yeah, one other thing is, primarily, if you look at how ISRO has been doing, one of the key activities of ISRO is to develop capability within the country. Capability within the country to make use of the space technology for various applications, not only for our own use, but also to make use of this capability for taking a share of the international market when it is available. So slowly we are building that, and as you have seen, Polar Satellite Launch Vehicle is an excellent opportunity, and we at ISRO have been trying to increase the pace of realization of these so that we can put more satellites into orbit. And the industry, like I said, we have a huge amount of industry contributing to this, and academic institutions also contributing. So in our interest in general is to enable people in our country to grow in the space business. As you have seen already internationally, there are a large number of private companies which are working for space programs, whether it is space adventure, space tourism, space exploitation, space exploration. In all these areas, there is a tremendous opportunity, and we would be extremely happy to support Indian entrepreneurs and Indian entities taking a share of that.
Sir, can we make ISRO a household brand name by supporting various day-to-day products, which not only generates additional revenue and resources for you, but also makes the brand very popular in all the activities to everyone, just like NASA has done?
Yeah, it definitely is a possibility, and more and more outreach activity, reaching out both to the young students as well as to the household. Opportunity exists, but as you can visualize, ISRO as an organization, when it is looking at, it doesn't have infinite resources and a manpower. So we are still struggling to make sure that the pace at which we are doing our primary activity, that is going on. Probably we'll be more than happy to support somebody who can do this job for us.
So just your brief comments on how collaborative is the entire space center across the world, and how competitive, because I think there have been instances where ISRO has been slowed down by international countries. So just your sense of collaboration and competitiveness in this space.
Yeah, the primary thing is only when you are capable and when you have demonstrated a certain capability, others will be willing to work with you. That is one of the things. And then it is truly in the same way. Today we have, for example, we are working with a program called NASA ISRO Synthetic Aperture Radar Mission, which is likely to be launched in 2021. And we have also worked with KNES for Saral and Megatropics. So once you have established a capability in yourself, others will be willing to work with you. Until you reach an equivalent capability, nobody is willing to do any collaborative work. And also there are entities which will try to prevent you from acquiring new capabilities.
So one small query, this is not really to do with space research, but how do you propagate in your organization the values of excellence with frugality?
Okay, I think what has been happening here is right from its inception, the whole objective of ISRO has been for addressing a specific problem we are facing, how to make use of a new technology. And then you are trying to do this within the resources that is made accessible to you. So because of this, when the necessity becomes the mother of invention, just to give you a couple of examples, even way back when we did our INSAT program, at that point of time, the world did not have in a single satellite the three services that were being provided, whether it is broadcasting, communication, and meteorology. All three were combined in one satellite. And we had to do that because we could not afford 3 independent satellites and 3 independent launches. And also for this, a new capability of a 3-axis stabilized configuration was to be brought in. So and then later you saw, for example, Navik satellite making 7 compared to 28 to 32. The whole purpose has always been to solve a specific problem. What is the best way that make use of all the technology that is accessible to you? What is not accessible, you develop yourself. And this kind of a drive is what has made both innovation and frugal is by necessity. You do not have the luxury of doing things otherwise. So that's how these two things have come together. And since the prime objective has always been making use of technology for solving problem, not developing the technology for the sake of technology. And it is this which has also made the difference that when something is accessible to you, make use of it. Don't be too rigid that you have to do everything indigenization. But there are also a set of things which you can be denied, you cannot get. So for that, you make indigenous efforts.
Mike.
Mr. Kumar, all this was very, very impressive. One has been hearing about what ISRO does from time to time, but seeing it in one capsule is totally remarkable. My question is just follow up on what was mentioned about space missions earlier. In the 60s, the entire objective was to, at least between two countries, to race each other to the moon. Now, I think the last time a man was put on the moon was about 40 years back when the Apollo mission ended. But after that, nobody really talks about it. China, of course, talks about getting onto the moon before 2030. Would you say that the entire Apollo mission was an exercise in futility because no other country seems to be keen to get onto the moon and sees no advantages from doing that?
No, I don't think you can say it's an exercise in futility because human nature is, if there is something it wants to do. For example, when somebody was asked, why do you want to climb Everest? He says, because it is there, I want to climb. Same way, see, today people are talking of, for example, Elon Musk is talking of making humankind a multi-planetary species. So like that, this kind of development, there are two things here. One is a target like that generates a lot of new emphasis and drive for technology development. And those technologies which are developed find many other uses. So it's always important that you have targets which are not easily achievable so that there are a number of people who work towards that and achieve the process. And that process is, in a way, in some ways, you can say it takes things forward. And in that context, the technology that was required for putting man on moon did make a huge impact in American economy itself. So to that extent, I won't say it's a futility. But then why it did not continue, etc., if that is a question, then probably what is available on moon, and then if you want to make use of it for other applications, the cost of doing that, what is finally what determines. That means the economics of the whole thing. So if the economics of the thing is not appropriate, then it doesn't move forward. So you will always have some new things done, and if the economics is good, it will prosper. Otherwise, it will get into the sideline. That's what would be my take.
Any other question, or otherwise I can proceed? Wow, what a great start to discovery of ways to new India, which is our theme today. Thank you very much, sir, for giving a deep insight into the use of technology for the socio-economic development of the country and how technology touches everyday common man's life. Your presentation is also a befitting answer to all those who have a very prejudiced view about India's space program and always criticize that why do we need to spend so much money amidst so much poverty. This presentation needs to be sent to all those people, and then they would know that it's not money is spent on a space program, but it is a money which is being spent on the welfare of this country and has the potential of the economic prosperity to this country. Innovation and collaboration. You reinforce this idea. We in State Bank of India for quite some time have taken this path of innovation and collaboration because we sincerely believe that the new age economy which is emerging in the world and in India today, the only answer to survive is innovation and collaboration. We made a small beginning last year by setting up aside 200 crore for these activities, where this money will be spent on innovation and collaboration with fintechs, with the startups, and it is a very structured program, and despite all the limitations which a public sector institution has to face, we are moving ahead with this program. ISRO, this is one name which fills every Indian with a sense of pride. Your head goes up as soon as you hear the name ISRO. Probably chest girth also goes up by minimum 2 inches. So we are really, really very proud of all the achievements which ISRO has to its name and has put India into the forefront of space technology. India's eternal quest for discovery of self and cosmos continues. This is just another day-to-day in that process. And I'm very sure that at the end of that today, we will have many new ideas. How do we take the banking in this country forward and the economy in this country forward? So to start with the first panel will be the CEO panel chaired by our chairman, Mrs. Arundhati Bhattacharya, on the topic, Translating Vision into Reality, What Should Leaders Do? Comprising of a very diverse panel, this session will discuss the role of leadership in guiding the destiny of New India. How leaders can translate the organization vision into reality while contributing to the growth of New India is the central agenda of this panel. Subsequently, there are 3 more panels and one tete-a-tete with Shri Rajesh Agarwal, Honorable Finance Minister of Uttar Pradesh. So the theme of all the discussions is very exciting, very carefully thought of, and a lot of you are really going to enjoy it. So thank you very much, sir, for a great presentation. All of us, we knew some bits and pieces about what is happening, and it was really an eye-opener. And we at the State Bank of India really thank you for your time and the great presentation. Thank you very much.
Thank you so much, Mr. Kiran Kumar. Thanks, Mr. Rajnish Kumar. May I invite Ms. Bhattacharya back on stage to please present a small memento to Mr. Kiran Kumar as a token of the appreciation. And this is also interesting. This is actually a painting which has been crafted by specially abled women and children from the NGO Om Creations, which is one of the many NGOs that is supported by SBI. Gentlemen, thank you so much. A leader does more than just lead. A leader inspires. It is the leaders of the day who hone the skills on which the organization of tomorrow thrives and continues to grow. And if you translate this to a country, you will find that the scope and need for effective leadership expands manyfold. This is the theme of the first set of panelists, and they're looking to explore this actually, translating vision into reality. What should leaders do? So with that, if I can invite our panelists for the first round of discussions, Mr. Amitabh Kant, CEO, Niti Aayog, Ms. Zia Modi, founder and senior partner, AZB and Partners, Baba Ramdev, founder, Patanjali Group, and Mr. Naveen Surya, managing director, It's Cash. And moderating this panel discussion will be SBI chairman, Ms. Arundhati Bhattacharya. So if I could request everyone to come on stage in just a bit. And while we set up the stage, just a brief introduction of our panelists. So Mr. Amitabh Kant has actually been one of the key drivers of some of Brand India's most recognizable campaigns, Make in India, Incredible India, God's Own Country. You'll remember all of them. And he's currently steering the National Institution for Transforming India as its CEO. Ms. Zia Modi, she's a corporate lawyer par excellence and commands a team of 400 legal professionals and is not just at the forefront of everything that's legal in the country, but she's also at the forefront of every important debate of the day.